Tonight on Dark Matter Nap, we are going to explore a cosmic glitch that breaks the very rules of cause and effect. Imagine waking up tomorrow morning, flipping the light switch in your room, and instead of the space instantly illuminating, you see a slow, luminous wave of glow crawl across your walls like thick syrup. You look out your window, and vehicles driving down the street appear warped, their shapes compressed into strange, abstract patterns. The cosmic speed limit of our reality has just violently dropped. The speed of light, which normally cuts through the void at a blistering 186,000 miles per second, has suddenly slowed down to just 30 miles per hour. It sounds like a surreal, dreamlike fantasy. But when you subject our universe to this sudden slowdown, you unlock a sequence of physical and atomic catastrophes that would immediately rewrite the laws of nature. Tonight, we will break down the exact mechanical timeline of a slow-light reality. We will see why walking down the street would trigger a blinding atomic flash, analyze how the stars in the night sky would violently reshape themselves, and explore the immediate catastrophic shutdown of the matter that makes up your own body. Before we watch the lights of physics slow down, take a second to like this video and subscribe to the channel. It helps us reach more curious minds like yours. Now, settle in, turn off the lights, and let's face the slow dawn. To understand the immediate visual and physical breakdown of this scenario, we have to look at what happens to your everyday perception when you move faster than the speed of light. In our current reality, you can never outrun a photon. But if light slows down to 30 miles per hour, any standard car driving down the highway, or even a person sprinting down a path, can easily exceed the cosmic speed limit. The exact millisecond an object moves faster than the speed of light through a medium, it triggers a phenomenon known as Cherenkov radiation. It is the optical equivalent of a sonic boom generated by a supersonic jet fighter. As a car accelerates past 30 miles per hour, it punches through its own light barrier, releasing a violent, blinding shockwave of pure blue light. The streets would be illuminated by these high-energy flashes. Simply driving down the road would generate a continuous, radioactive blue glow that would instantly blind anyone looking toward the street. The quiet darkness of our cities would transform into an unyielding, high-energy matrix of blinding light waves. But the visual distortions would get even stranger due to the extreme mechanics of relativistic Doppler shifts. When you move at a significant fraction of the speed of light, the light waves ahead of you and behind you are violently compressed and stretched. If you are jogging down the street at 15 miles per hour, which is now half the speed of light, the visible light bouncing off the environment ahead of you would be compressed, shifting its color toward the high-frequency blue and ultraviolet spectrum. Meanwhile, the light behind you would stretch out, shifting toward the low-frequency red and infrared spectrum. Your eyes would experience total color blindness. The world ahead would vanish into an invisible glare of ultraviolet radiation, while the world behind would dissolve into a dark, heat-mapped blur. This would be accompanied by a severe distortion of geometry called Lorentz contraction, where objects ahead of you would physically appear to compress and bend, warping the stable architecture of our cities into a twisting, melting hallway of glass. As your eyes struggle to process this melting reality, a much more severe catastrophe would take place within the core engines of our global technology. Our modern electrical grids and computer networks are completely dependent on electromagnetic waves traveling along copper wires and fiber optic cables at near-light speed. The exact second the universal limit drops to 30 miles per hour, information propagation hits a screeching halt. Data packets traveling through internet cables would slow down to a literal crawl. A digital message sent across a city would take hours to arrive, and a query routed across an ocean would take days. The global internet grid would instantly fracture into isolated, non-functional nodes. Automated control systems regulating nuclear reactors, electrical substations, and industrial manufacturing plants would miss their microsecond timing markers, triggering massive, cascading blackouts across every continent. Modern industrial civilization would hit an immediate standby state, isolated by the sudden, heavy sluggishness of its own signal paths. The environmental feedback loops would multiply across the natural landscape within hours. Our atmosphere relies on the constant, high-speed movement of photons from the sun to drive thermal patterns and weather grids. When sunlight slows to 30 miles per hour, the thermal energy taking 8 minutes to cross the space between the sun and Earth would suddenly require years to complete the journey. The light hitting our upper atmosphere would experience an immediate, severe data congestion. Photons would pile up at the edge of the sky, creating a massive high-density thermal boundary layer that would superheat the upper atmosphere, while the surface below plunges into an immediate cryogenic freeze. The seasons would cease to function, and the global water cycle would hit an absolute standby state as the oceans freeze over under a dark, frozen sky. Humanity would be forced to retreat deep underground into pressurized volcanic bunkers simply to find sustainable ambient warmth. But the ultimate, unyielding executioner of a slow-light reality is an absolute law written into the subatomic mass energy equation of Albert Einstein, E equals mc squared. This famous equation proves that energy and mass are fundamentally interchangeable, bound together by the square of the speed of light, which is represented by the letter c. The speed of light is not just a tracking metric for photons. It is the conversion factor that dictates how much binding energy holds atoms together. E equals mc squared. When the value of the speed of light drops from 186,000 miles per second down to 30 miles per hour, the value of the speed of light squared flatlines into near nothingness. The nuclear binding energy that holds atomic nuclei together would instantly evaporate. The subatomic forces keeping protons and neutrons locked in place would weaken completely. Every single atom in the universe would undergo an immediate, violent structural dissolution. The solid matter making up our skyscrapers, our oceans, our planet, and the very cells inside your biological body would lose its atomic stability. Matter would literally melt from the inside out, turning into a uniform, non-structured cloud of loose subatomic plasma drifting blindly through space. The universe would systematically erase its own complexity, turning the magnificent masterwork of stars and life back into a smooth, cold soup of loose particles. We look at the speed of light as a frustrating cosmic barrier, a rule that keeps us trapped inside our local solar cradle, preventing us from easily visiting distant alien worlds. We look at the stars and imagine building machines that can cheat the physics models to slide across light years of distance in a weekend. But in reality, that blistering speed is the exact mechanical anchor that permits structure to exist. We are only solid, we are only alive, and we can only think because light is screaming through the dark at maximum velocity. The cosmic speed limit is not an engineering problem to be overcome by our future generations. It is the physical operating framework of reality itself. Thank you for joining me tonight on this deep journey into the source code of physics here on Dark Matter Nap. If this exploration of a slow-light universe challenged the way you look at the morning sky, or made you appreciate the invisible constants that keep us safe, please take a moment to like this video and subscribe to the channel. Your support helps us continue to create these late-night deep dives into the mysteries of existence. The next time you flip a light switch or feel the instant warmth of a light wave on your skin, appreciate it not just as a simple daily routine, but as a beautiful, vital shield that preserves the very atoms of your reality. Sleep well tonight, knowing that our universe is still running at full speed through the dark. Good night, and may your dreams reach far beyond the horizon.